Hey guys, so this is problem number 4. It says a block A support a pipe column and rests as shown on with knowing that the coefficient of the static friction at all surfaces of the contact 0.25 and that theta is equal to 45 degree. And then we ask us to determine the smallest force P required to raise the block A. So which means that this thing is at an impending motion. So F will be equal to mu as N. And then draw the free body diagrams. Okay. So I basically just work out this problem with you guys so that we can just go do this fast and quick. So it won't take much of time. So here's the free body diagram as shown. So first I draw the free body diagram of the wedge A, wedge B and A. Okay, we know that the P is going in that direction, and then so the friction will be going in the opposite direction, right? And then here's the free diagram of the uh, object, and which I think this will be easy for you guys because I think we did the similar questions in the class and also in my essay session. So this free diagram will be easy for you guys. Okay, and then next thing is that I have to consider the free diagram of this object, which is the free diagram of A, because this has the less unknown force. I only have 4 unknown force compared to 5 unknown variables on wedge B. Okay. Okay, so first, so I do the summation of the forces in the x direction for the wedge A, which is the object, and then we know that in the x direction I have this n2, okay, which is going to the right, and then minus n1 sine 45 because that will be the n1x right here, as you can see. All right, and then minus the f cosine 45, which is right here. So this would be the f1x, right? And this would be the f1y, right? And then the theta is right here. So that's why I consider f1 cosine of 45. And I know that the f is equal to mu n1, okay? So I replace that. And then I basically just rearrange this equation in terms of n2, okay? So as you guys can see right here, okay, so this is 0.25, which is the mu. And then I just basically like get this n1 out because they have the common term n1 right here. All right, and then uh, get it in terms of N2 and then simplify it down. So I get N2 is equal to 0.884 and 1. And then, and then I do the summation of the force in the y direction. So in the y direction, excuse me. So in the y direction, I have this negative, I have this 3 kilonewtons that going downwards, so negative 3, minus the F2, okay? And then plus the N1 cosine 45, which is the N1y. And then minus the f1 sine 45, which is the f1y. And then basically I'm just break f2 and f1 down into mu sn2 and mu sn1, okay? So that, and then I replace n2 right here with 0.884 n1, okay? And then basically in this equation right here, only one unknowns, which is the n1 right here. So basically just solve for n1 so that I get n1 is equal to 9.67 kilonewtons. Okay. So after I find n1, I can move on to the free body diagram of the wedge B. Okay. So as you can see right here, so first I consider the force in the y direction. So in the y direction, I have this n3, right? And then plus the f1 sine 45, which is the f1y right here, and then minus the n1 cosine 45, which is the n1y right here. Okay, and then basically just break f1 into mu s n1, and then so that in that equation, I know what my n1 is. My n1 is equal to 9.67, right? So that only one unknown in this equation, which is n3. So I get my n3 is equal to 5.12 kilonewtons. Okay, and then summation of the force in the in the x direction. So in the x direction, I have this force P and then the F3. Okay, so P is going to the left, so it's negative, and then F3 is going to the right, so it'll be positive. And then plus the F1 cosine 45 and plus the N1 sine 45, which will be the forcing the component forcing the x direction. Okay, and then I'm just rearrange this term in terms of p because that's the thing we're trying to solve. And then I know that my mu is equal to 0.25, and 3 I found it above, which is 5.12, and then plus the 0.25, which is a mu, multiplied by n1, which is the 9.67, which I found earlier, and then cosine 45, plus the n1, which is 9.67 sine 45. So in this equation, we know everything except the p. So just simply plug this into a calculator. I get my p is equal to 9.8 kilonewtons. Okay, and also I'm gonna post my uh, I'm gonna post the solution on the Google Drive too, which will be on Monday after you guys watch the video.